right, so what I'm going to do here is do the calculation question 1E. So we are asked here for the average number of moles of EDTA used in the titration. So first thing, I'm just going to fill in what I know. I'm told titrating, and I titrate 50.0 centimetres cubed of the water with standard EDTA. The average volume of 0.01 molar EDTA that react with the 50 was 9.3 centimetres cubed. So part I, I'm asked the average number of moles of EDTA used. So I have 0.01 moles in a litre, which is 1,000 centimetres cubed. My average titration result for EDTA is 9.3 centimetres cubed. So that's going to give me, multiplying by what I know, divide by the bit left over, 9.3 by 10 to the minus 5 moles. That's my answer to part A. Okay, that's the average moles. Then we're asked the number of moles of the M2 plus ion in this. Okay, so I have to get my ratio of my EDTA is to my M2 plus, 1 is to 1. So if I've worked out, I have 9.3 by 10 to the minus 5 moles of my EDTA. I also have 9.3 by 10 to the minus 5 moles of EDTA, and that is in 50 centimetres cubed. So that is my answer to part 2. Part 3 then, we're asked for the total hardness of the water expressed in grams per litre. So I've worked out that I've 9.3 by 10 to the minus 5 moles in 50 centimetres cubed. I need to work out how much is in 1,000 centimetres cubed. So multiply by 1,000, divide by 50, which gives me 1.86 by 10 to the minus 3 moles. I'm asked for grams, so I have to work out my grams. Number of moles equals mass in grams, divided by my relative molecular mass of CaCO3, 40 plus 12 plus 16 by 3 gives 100. So 1.86 by 10 to the minus 3 multiplied by 100 gives me an answer of 0.186 grams per litre. That's my answer to part 3. And finally then, I'm asked for it in ppm. So I have to multiply by 1,000, which gives me 186 ppm.